this video, I will explain to you what is general relativity and also what is gravity like.
Why do objects fall? Gravity. What did you know about gravity? Gravity is formulated by Isaac Newton. Newton explained that gravity is that all things in the universe have mass. It is fundamental phenomenon in the universe that tends to bring an object closer together.
General relativity is a theory of space and time. The theory was formulated by Albert Einstein to account gravity, and it was published on 1915. The central idea of general relativity is that space and time are two aspects of space-time. Space-time is curved when there is matter, energy, and momentum resulting in what we perceive as gravity.
So what was Einstein's discovery? So, let's see how it works.
For example, the whole universe is like a fabric sheet. That sheet is combined with fourth dimension time, becomes space-time. Einstein says that curvature in space-time are responsible for gravity.
Let's take a fabric mat as an example. Let the fat man sit in the middle of it and make the skinny man sit on the edge of the mat. Then the mat bends inside where the fat man is. So the skinny man is automatically pulled towards the fat man. The fat man does not exert any force, and even if he doesn't touch him, the skinny man is drawn towards him.
Similarly, gravity occurs for everything in the universe.
As the sun bends space-time, the earth is attracted towards it. It is not a force. As space bends, it has an impact on the objects on the curve. Mass tells space-time how to curve, and space-time tells the mass how to move. Massive entities like stars and galaxies are able to warp space and time considerably that even the behavior of the light is affected. If the absence of gravitational field, light would just follow a straight path.
Light is known to always go straight line at constant velocity.
Example, if you throw a ball on the ground, it will go down. And if you throw a ball from an acceleration lift in space, it will travel in curved path.
Will the light bend or can be bent? Yes, it will bend, according to Einstein.
Another consequence that arises from the principle of equivalence is that light is bent in a gravitational field. The ability of gravity to bend light is called the gravitational lensing. It is possible if there is something called space curvature. This was confirmed in 1919 by measuring position of stars during solar eclipse. Gravity had bent light itself because space-time had been bent. Light always travels straight, and because its path is curved, it also bends. Today, gravitational lensing is measured by the deflection of radio waves emitted by distant galaxies called quasars. The idea that gravity affects the light is seen in the concept of black hole. Black hole. Black hole is a very massive object whose matter is mostly contained in one single point. We call it central point, a gravitational singularity. The curvature of spacetime is so great that all straight lines point in this direction, where no object can hope escaping the black hole. Even for light rays. Black hole emits no light, neither matter nor radiation that can escape it. We see it as an entirely black sphere.
Example. If we are closer to it, it is impossible to stay stable to orbit around the black hole. And if we are far from it, it is possible to gravitate in a stable manner around the black hole. An object passing around the black hole will slightly deviated but still be able to escape its attraction. Particularly, light rays coming from distant stars change when they get close to the black hole.
The gravitational redshift is another result of the general relativity. Gravity affects time by causing it to slow down. The greater the gravitational field, the greater the slowing time. The closer we are to a source of gravitation, in other words, a massive object like the sun of the earth, the slower the flow of the proper time at the surface of the earth.
Let's take this an example. If we compare the internal clock of two observers, one being at the base and other at the top of the Eiffel Tower, we would see that the internal clock of the person at the bottom is slightly slower since the person is closer to the center of the earth. A person at the bottom of the tower ages a microsecond less than the person at the top. This time dilation effect is very subtle but extremely important. On Earth, it is crucial to take into account when designing GPS satellites to ensure the synchronization of internal clocks.
To sum up, general relativity gives a comprehensive framework to grasp the phenomenon of gravitation, where a massive object lies in space-time. It distorts the geometry around it, curving straight lines in time and space, which in turn leads to the deviation of surrounding objects and modifies the perception of time.
This thought experiment is not a simple one. This is the greatest thought, not only in human history. This is simply explained gravity, but also showed us how the entire universe works.